welcome to this Integrated Math 3 video series. This is Unit 2 in the series, and this is Lesson 4 in that unit. Today we're going to talk about factoring techniques and how to use those to simplify fractions that involve polynomials. So before we get into that though, try our warm-up for today. We've got 5 problems here for you. So take a second and try to do those. Alright, in number 1 here, we've got 2 fractions that are multiplying. We're multiplying fractions. We multiply their numerators and then we'll multiply their denominators. So 4 times 3 in this case is 12. And then 7 times 5 is 35. Well, we might think about if there's any common factors between 12 and 35. I don't think there are, because we have 7 times 5, and then here we have 2, 6, and 3, and 4. So then they don't have common factors, so this is the simplest that we can write. Number 2 here, difference of 2 squares, x squared minus 49. If you think about it as x squared minus 7 squared, it factors into x plus 7 times x minus 7, as we talked about a few videos ago. Number 3, this is an interesting situation that you might end up with where you have the sum of an arithmetic sequence. So we have 3, and then if you add 6 to 3, you get 9, 15, 21. So we're increasing by 6 each time in terms of what we're adding to this sequence. And so back a long time ago, there was a guy named Carl Friedrich Gauss, and he came up with this method of pairing these up. So we actually have a bunch of pairs of 36. In fact, we have not 36. Yeah, 36, because this is 15. 3 pairs of 36. So 3 times 36 is what we can do here, because we have 3 groups of 36. So 3 times 36, let's see, 3 times 30 is 90, 3 times 6 is 18, add those together you get 108. So this should be 108. So a good mental math strategy there if you ever run into a situation in which you're having to add up the terms in sequence, an arithmetic sequence that is. Alright, number 4, 37% of 9. So again, just take the numbers involved, 37 and 9, multiply those together. So let's see, 30 times 9 is 270. 7 times 9 is 63. We'll add those together and you get 333. Obviously 333 is way too much if you make sense and reason through this to be 37% of 9. 33.3, still way too much, but 3.33 makes a whole lot of sense here to be 37% of 9. Lastly, number 5 here, to factor this, we're going to have to first start by thinking about GCF. We always want to think about a GCF first. That's where we first begin, the first question that we ask. And so in this case, if there's a GCF, let's see here, looks like x cubed is a factor of each of those terms. So we can factor out x cubed from each of these and leave us with x squared minus 7, x plus 12. Which then that quadratic that's left over will then factor even further. So we have x cubed times, let's see, what multiplies to give us 12 adds to give us negative 7. What do y'all think? Yeah, negative 4 and negative 3. Again, the order doesn't matter there. If you were with us last video, we can then take this factored form and graph it. It would have x-intercepts of 0 with a multiplicity of 3, 3, and 4. And so you could graph that accordingly with a y-intercept of 0, which makes sense because if you have an x-intercept of 0, then the y-intercept is also 0. All right, so hopefully you're able to get those 5. Let's go ahead and hop into our lesson for today, which again is all about factoring polynomials to simplify fractions. So before we get into the algebra, I first want to start with a numerical example. So we have 20 divided by 15, and I want you to think about like how you would simplify that. So how would you go about simplifying that? Yes?
I just divide it all by 5.
Okay. So thinking about both of 5 being a factor of both of those, right? So let's rewrite this first as 5 times 4 divided by 5 times 3. since we have a fraction with a common factor in both the numerator and denominator, well, what's 5 divided by 5? 1. Now, sometimes you hear people say like they cancel or whatever, but really it's a simplified 1, right? You're simplifying this to be, or reducing that to be 1. 5 divided by 5 is 1, so you have 1 times 4/3 is just 4/3. So again, if we go back through the process here, we found a common factor, simplified that to 1, and then we reduced it to whatever was left. And that's exactly the same process we're going to go through, but with polynomials. So we've got a quadratic divided by a quadratic right here. So I'm going to give you a second to, again, try to find a common factor. And so to do that, you can just factor both of them and see if there's a common factor that you can reduce. So let me give you a second and see if you can try that on your own. Okay, so with this one, we can factor the quadratic just like we factored the numbers in our last example. We can factor these quadratics and see if there's a common factor in both the numerator and denominator. So for the top example, if we factor this into x plus 4, x plus 1, the denominator factors into x plus 6, x minus 6, and x plus 4. So we have a common factor here of x plus 4. So x plus 4 divided by x plus 4 is 1, leaving us with a final simplified version here of x plus 1 divided by x minus 6. So that's kind of how we do this. The overall process is to factor, find a common factor, and then reduce and see what's left. Any questions about that
So
particular?
you leave it as x plus 1 over x minus 6?
Yes.
Oh, okay.
Yep. One thing that you might want to mention here is some of the restrictions. So we cannot divide by 0 for a lot of various reasons, but we cannot divide by 0. So one thing sometimes we do at the very end here is we say that this is equal to this and is defined for all values except for what makes us divide by 0. So what value of x would make us divide by 0 here? 6, right? Because 6 minus 0, 6 is 0. And so 6 would make us divide by 0. But then we actually have to look throughout the entire problem. So 6 would make us divide by 0, but also what? What would make this 0? -4. So -4 would actually make this make us divide by 0. So you have to look out throughout the entire problem to state these restrictions. Because if x is -4, you're actually going to have 0 divided by 0, which is an indeterminate form. So that's kind of a weird case. Right, it does not equal 1. Yeah. In fact, 0 divided by 0, we're kind of getting a little bit off on a tangent here, but there are 3 conflicting rules here, right? 0 divided by anything is supposed to be 0, right? But anything divided by 0 is supposed to be undefined. But then anything divided by itself is supposed to be 1. So is it 0, is it undefined, or is it 1? So it's an indeterminate form is what we call that. So anyways, once you simplify this, state your restrictions. That can always be helpful. All right, so we have a number of different examples here. I'm going to give you a chance to try these, and I'll probably need to move the camera a little bit closer so you can see some of these. Okay, so try these and see what you can do on these. Okay, so I've put the answers up on the screen here. So take a minute to check your answers, and then we'll go through maybe a couple of these together. So the first one is the difference of 2 squares in the numerator. It factors into x plus 3, x minus 3. The x plus 3 in the numerator simplifies with the x plus 3 in the denominator to 1, leaving us with x minus 3 left over. Let's do another one maybe down here. How about this one? We'll pull this off to the side here. The top one, or the numerator, factors into x plus 4, x plus 2. The denominator is x plus 4. So the x plus 4s reduced to 1, leaving us with x plus 2 left over. So that's why that answer is there. All right, so check your answers for the rest of these, and if you need to, go back and see maybe how these result from those. All right, in this next example, we've got a cubic divided by a quadratic. So take a minute and see if you can factor both of these and see if there's any common factors that you can use to simplify. All right, so in the top one here, the numerator, we can factor by grouping. So we can take out an x squared, leaving us with x plus 5. We can also take out a -4, leaving us with x plus 5. I'm just going to focus on the numerator for right now. We'll factor it, and then we'll come back to the fraction itself. So we can take out an x plus 5 from the entire expression, leaving us with x squared minus 4, which then further factors into x plus 5 times x plus 2 times x minus 2. So far we've just rewritten the numerator in factored form. In the denominator, so I'm going to draw the line now of our fraction. In the denominator, see, that's going to factor into x plus 5, x plus 2, x plus 5, x plus 2, which will simplify actually quite nicely here. X plus 5 divided by x plus 5 is 1. X plus 2 divided by x plus 2 is also 1. So our final result here is going to be x minus 2. Let's go ahead and state our restrictions though. This is the case as long as x is not -5 or -2, because those are the values that make us divide by 0. So something to keep in mind there. All right? So we've seen some various problems here today of simplifying fractions with polynomials in them. We saw some that were quite simple. We started with numbers, then we got to polynomials, and then even cubics and that kind of thing involved. So that's how you can use factoring to simplify fractions that include polynomials.